Thank you, Stephan.
Thank you.
It is my pleasure to introduce our next speaker. He's a distinguished individual. He's an endowed professor in the Department of Pharmaceutical Science, University of Florida, and currently serves as the director of Center for Pharmacometrics and System Pharmacology. He obtained his bachelor's from Germany, from the University of Friedrich Alexander, and a PhD from University of Florida, and did a postdoctoral fellowship in Netherlands. His research focuses on development and application of physiologically based drug disease trial models, and he's published over 140 manuscripts, peer-reviewed manuscripts, and 8 book chapters and 2 textbooks, and he's received numerous awards. Please help me welcome Dr. Schmidt.
Yeah, thank you very much. That's too kind. I almost think you have the wrong guy here. But jokes aside, it's my distinct pleasure to be here. It's my first time and at this forum so far. I enjoyed very much. It's also good of course to connect with old colleagues and friends and make new friends. And so I intend not to change it in the next 40 minutes or so. So what I would like to do during my talk is, given that we have like a mixed audience between students, trainees, and then also other distinguished individuals in the room, is to provide or to jump a little bit back and forth between some high-level views and perspectives, and then go into some distinct examples. I'm not as courageous as Ben is, so I'm going to focus on one example, not on 14 if I counted correctly. So, and I will be focusing on the efficacy and safety of hormonal contraceptives. And that's a project that we've been working on jointly with colleagues from the University of Florida, colleagues at the UNT at the time, but also in pharmaceutical industry, and as well as the Bill and Melinda Gates Foundation and FDA. We have like well, if not, then I'll just use the. So how to advance the slides? Okay. All right. So again, allow me to take a step back and start with a high-level slide. And I borrowed this slide from Dr. Zinet, who's also a Gator, and now is the director of the Office of Clinical Pharmacology at FDA. And he started out with a provoking question on that slide and asking, is pharmaceutical R&D in crisis? And most of you in the audience have probably seen this slide or this graph in multiple forms or fashions. But I still think it captures the essence of what we are trying to do here, because what it shows is that if you look in terms of the number or the amount of money spent, and this is here in terms of billions, so not millions, but in terms of billion US dollars on R&D expenditures, over time, that you will see that the return on investment is diminishing over time. And so, of course, if that trend continues, at some point it will be no longer affordable to develop new drugs. And, of course, that's a scenario that we all would like to avoid. So the question, of course, is, why is that the case? And, how much does it cost to bring drugs to the market currently? And so here's some historic data seeing that, really the costs have skyrocketed since the 70s. To where we are now. And as far as I'm aware of, the latest cost estimates are ranging somewhere around $3 billion of bringing a new drug to the market. And so primary cost drivers are increased trial complexity, large clinical trial sizes, greater focus on targeting chronic and degenerative diseases, and then higher failure rates for drugs tested in earlier phase trials. And so that, of course, is apparent to like everybody working in the field. The more important question is, what are we doing about this? Because, again, if that trend continues, well, we are in big trouble. And so obviously both the industry as well as the regulators have reacted to this problem. You see also here that the science, not only in terms of, the different types of models that we use has evolved, but also how it's applied in terms of regulatory science, and how this has been also like implemented into congressional mandates. And so I'm sure most of you know also what the PDUFA is. So it stands for Prescription Drug Uses Fee Act, which is basically a congressional mandate to FDA associated with like a 5-year budget on what to focus on over the next 5 years. And you see that originally they started out, very applied. I mean, still applied, but with a very, basic problem, and that was to address a review backlog. And if you look then as time continues, you see that the problems that were tackled became more and more complex. Also, tools that were used became more and more complex. And if you look, closely to what's happening lately in PDUFA 6, and now we're in PDUFA 7, is that we are no longer in the space where we just say, okay, we want to use like a single tool. So, for example, here in the area of model-informed drug development, but obviously we need to integrate all evidence that we have at hand and then start comparing notes between different areas of precision medicine and real-world evidence, take patient voices into consideration. There's a lot of focus on rare diseases. So in other words, you have the totality of evidence in order to make a decision rather than saying, okay, my model this, my model that, VPC here, VPC there. So I think we really need to integrate and see what this all means in the overall context. And if it turns out by comparing notes between the models that we use and real-world evidence that we only explain like 3% of the clinically observed variability, then we are probably in a bad shape unless we are looking at a serious adverse events or at a subgroups that doesn't receive the full treatment benefit. Then we're in bad shape, and we probably should like switch focus and see what is really driving clinical variability. And so we try to highlight this that in an article that we wrote like a few years back, where we asked the question, pharmacometrics, PBPK, QSP, what's next? And really indicating then transdisciplinary approaches, for example, through the joining mechanistic and epidemiological approaches, may offer like a promising avenue forward. So Ben talked a little bit about, Ben being my second postdoc, talked a little bit about, the startings when I came as new faculty at the University of Florida, almost 12 years ago. And so I had like a little look around and say, what are the opportunities? Because, as many of you know, I'm not on the main campus. We were like on a satellite campus. At the time when we started, we didn't even have like a building. And so I was fortunate that I had a number of great mentors in my life. One of them being Larry Lesko, so at the time former director of the Office of Clinical Pharmacology at FDA. And so we looked at each other and said, like, so what do we do? I mean, we have like a couple of options here. Option number one is that we stick heads together and try to write like a bunch of R01s over the course of the next 2 years and hope they get funded. And by the time that they are scored, probably half of my tenure clock is up, and so I haven't really produced much. And so we decided that that's not something that we wanted to do. So we said, okay, probably, given that we are on an offsite campus or a satellite campus, investing into large, equipment and infrastructure is also not the way to go because, my startup package is not going to support that. So let's, think about what we can do, who we can collaborate with, and what the strengths are that we can bring to the table. And I'm probably a bit more honest than I should be at this point, but that's okay. And so when I thought about, what is it that we want to do, or what are we doing in pharmacometrics, is that, and this was me here when I was like younger and had more hair, is that we really use, data, limited data on either animals or individuals, plug this data into computer models to make then inferences about what's happening in the overall population or subgroups of the population that would then need adjustment of dosing or treatment regimen, maybe would need add-on therapy or have a contraindication. So we had, we were in a fortunate situation that we had, two other very strong groups, or we still have two very other strong groups at the university. One of them was pharmacoepidemiology. And so I made friends with Dr. Winterstein. And so when I thought about this, what they do, that seemed conceptually very similar. They just like thought about the problem the other way around, in a sense that they start with like real world evidence data. So really like big patient numbers using data from health insurance databases, for example, then use a method of iterative reduction of bias through the use of mathematical models to then again identify subgroups of the population that show a particular benefit risk profile. And so I thought, okay, that's kind of funny. So maybe we should talk to each other and compare notes to see, what we can learn from one another. Ultimately, it's of course important to bring our clinicians to the team. Precision medicine is of course like a hot area, and then basically use the identified genetic or non-genetic sources of variability in post PK and drug response to then see how we can implement those and ultimately provide better treatment to the patient. All right. So we basically followed that thought when we then set up the Center for Pharmacometrics and Systems Pharmacology. Obviously, it has evolved over the years. And so we basically started to organize ourselves along what I would call core competencies. So where we have the bread and butter population PK/PD modeling, but then obviously also have capabilities in terms of mechanistic modeling. I would put like PBPK or QSP efforts in that bucket. But then also have a real world outcomes pillar and an artificial intelligence pillar, so to make sure that we really can bring like different core strengths to the table to answer clinically relevant questions and ultimately also provide an environment where students and trainees can learn in a team-based setting, in an applied setting, and bring then this expertise to the job site. All right, so let me now switch gears to the example I want to talk about. And so the example I picked for today's talk is hormonal contraceptives. And so the question that I always ask my students when we think about research, so why do I care? Why do you care? What is the question that you're trying to answer? And so the question that we had here is, do drug-drug interactions have a significant impact on hormonal contraceptives? And so when you think about drug-drug interactions, they're usually bad. I mean, oftentimes you talk about inhibitory scenarios. Oftentimes they are cytochrome mediated. This was similar in a way, but it was not an inhibition, but it was an induction in 3A4 that was of concern. So why is that? Because we have about 220 million women in developing countries that like access to modern contraceptives. And the evidence suggests that we have about like 50% unintended pregnancies, which is of course a huge socioeconomic problem in this area. And if you look at the hormonal contraceptives that are typically used, and I provided a list of the 6 most commonly used one here, and they're typically used in combination with estrogen, that you will see that they're all CYP3A4 substrates, so an induction may matter. And what makes the situation even worse is that when you look at what's happening in terms of comorbidities or co-medications, that in low and middle income countries, you have a fairly high prevalence of HIV and TB. And if you look at medications that are used to treat HIV or TB, then you see that in part you have strong CYP3A4 inducers on the treatment panel. And so I said, okay, let's have a look. We faced a couple of challenges along the way, and I need to update this slide here. There's a newer guidance out there, and we saw that when the progestins that we're interested in, these are drugs that were introduced decades ago. So in part, formal exposure response analysis are not available. However, we have extensive clinical experience, and even if you wanted to generate formal exposure response relationships, you face another challenge, because I mean there are contraceptives. If you go in the range of EC50s, then you switch the focus from contraception to conception, and I guess that's not something that we want to do, and I think that would also no IRB worldwide would approve that. So the question is then, of course, what do we do here? And so what we proposed at the time is that we should really look at different data sources and different modeling approaches. So specifically to look at the use of model-based meta-analysis approaches to extract dose-response relationships from the literature, then use PPPK models to translate these doses or these dose-response relationships into exposure-response relationships that can also then be used for new formulation development. And then ultimately compare nodes to real-world data to see where we are both in terms of efficacy, tolerability, and safety. So another word here on challenges, but also opportunities that we faced along the way. So we know, of course, that there are different dosage forms available. I'm specifically only going to talk here about oral formulations and implants. I'm not going to touch IUDs during today's talk. And then ultimately, of course, again, what you want to do is connect dosage form to the systemic exposure that you'll see. We know that body composition, so body mass index, plays a role. We know that DDIs are of interest. And all right, hope it was not that boring that the screen went off. Yeah? Yeah. It's an unexpected adverse event and off target. Screen sharing has stopped. Okay, yeah. Sure. Yeah, I'm not sure if like folks online can still hear us.
Early comments about how do you integrate system biology, pharmacometrics with precision medicine and pharmacoepidemiology, right? Put them together, and the grant submission stuff. I think that's really not a joke. It's just for real. So my question is for faculty in your department or your center, when they submit NIH grants, which study section do they go?
Ooh. This is a great question. I mean, I don't think there is a general answer. Oftentimes you are, at least for quantitative faculty, you're not necessarily a PI, but you're like a, co-I. For example, an R1, if we have like, center grants like U18s, then it can, you can be the PI or lead on that, particular mathematical modeling core. When it comes to study section, it very much depends on the therapeutic area. So I think we have, applications in diabetes, NIAID. So I don't think there is necessarily like a strong answer. I think we are in the fortunate situation that NIH is not the only funding source. I think we have excellent partners, many of them in the room from pharmaceutical industry or from foundations, and I'm a big fan of risk mitigation. I mean, if you think about a portfolio, I mean, like a stock market, you're not just putting all the eggs in one basket. So you kind of want to risk mitigate, diversify the portfolio. I do the same, or I at least do the same in terms of funding. So there's a mix of foundation, industry, FDA, and NIH. Great. Yeah, so welcome back to Folks Online. Just work on like pulling the slides up really quick. So bear with us for a second. Nope, the wrong ones. Yeah, that's not mine. Yeah, that. Let's go into full screen mode. All right. Okay. No, no worries. That happens. Thank you very much for your help. Yep. All right. So where were we? Here. Okay. So what I was saying is that we know that certain factors, demographics, BMI, play a role. DDIs, can play a role. And then ultimately, of course, you want to link this to response. What I'm going to focus on here in this talk is on efficacy and usually Pearl Index. So it's it's a measure for unintended pregnancies per 100 women years is the efficacy index. I'm sorry? Okay, perfect. And so we are, oh, okay, great. Thank you. All right, and so so I'm going to focus primarily on efficacy, but we have also, obviously looked at evidence for bleeding, specifically breakthrough bleeding or breakthrough bleeding and spotting, because obviously if you start taking these medications and then have significant intermenstrual bleeding events, that I would think that this significantly decreases your susceptibility to continue taking this drug. So, and obviously the best drug can't work if you don't take it. Unfortunately, we looked at VTEs here as well, but fortunately we didn't find a lot of data in the literature for this relatively serious adverse events, and then ultimately link this then to real-world population data in terms of unintended pregnancies, adherence, and then also DDIs. So in terms of data, so the data that you usually get for PK studies that you have sample size of like 50 subjects or less, it's oftentimes a PK only study. If you look at then the response trials, it's a much larger sample size. We usually look at about 3,000 subjects, but it has a limited dose range, for the reasons mentioned. And then ultimately, if you look into real-world patient databases or real-world evidence databases, we typically talk about starting sample sizes of like 1 million or more. And in this particular case, I think we had something around like 16 million patient records to start with. And then obviously that boils down over time. So I guess, in isolation, none of these analysis or data sets gives you the answer. But if you link the analysis, as outlined here, then, opportunities arise in terms of then being able to inform formulation design, optimize dose selection, optimize trial design, look at the impact of variability, and ultimately also inform drug labeling. All right, so as pharmacometricians, and having like written book chapters and textbooks, we love this type of conceptual graphs where we basically have like mean curves going up and down, and we draw like thresholds across and then call it a day. Obviously, this is somewhat oversimplistic because I mean obviously both the mean curves as well as these thresholds have like variability therein. So in other words, how much forgiveness do we have for both minimum efficacious dose as well as toxicity? There is probably not only one line at the upper end of the interval. There is probably multiple shaded areas. One, for example, due to the occurrence of bleeding events, which oftentimes subside over the course of 3 to 6 months. But then also when it becomes more serious and there is some data in the literature on DMPA, so long-acting progestin, that it can have adverse effects on bone health. And so then the question is, of course, are you willing to accept that trade-off in terms of the benefits that you receive for contraception? All right, so let's have a look what we did. So we actually worked with a private company by the name of Accelera to help us extract data from the literature. So we started to look, or we originally retrieved about 310 references from the literature and then manually curated to them and boiled them down to 9 references that gave us dose response data for oral, levonorgestrel, and Pearl index. And so what you see here is Pearl index on the y-axis versus the levonorgestrel on the x-axis. And the literature data that you get, what you'll see is at the approved dose levels, you're really at the top of the exposure response profile. But then obviously, if you take like an enzyme inducer, you shift the effective dose to the left. And then the question becomes is, when does that curve start to go up? In other words, how much forgiveness do we have? And so in order to answer that question, we bored like 2 data points. Number one was the baseline fertility data out of WHO. And then here we also bored some data from Plan B, so levonorgestrel only. And I recognize, of course, that we are somewhat, probably overly conservative because we know that we have a combined drug product of levonorgestrel and ethinyl estradiol. And ethinyl estradiol in and by itself has also some contraceptive properties. Nevertheless, we were then able to fit an MBMA model to it, and that put us into the position to determine doses necessary to achieve Pearl indices of 2, 3, and 5. Okay, so as I said, the next step would then be to translate this dose into systemic exposures through the use of a PBPK model. I show you the workflow here on the left. For the sake of time, I don't want to go into great detail. But what I want to point out is that we were able to predict the concentration time profiles here relatively well. Concentrations here shown on the y-axis over time in days on the x-axis. The black solid line is the mean model predicted line. The shaded area is then the confidence interval around the predictions. And then the blue symbols are the steady state concentrations that we got from the literature. That red part of the graph here on top recognizes that we have like a binding partner, a sexual hormone binding globulin that can change over time. And so we consider this in a model recognizing that body composition, so obesity and ethinyl estradiol as well as rifampicin can impact SHBG expression, and then obviously also interact with the cytochrome 3A4. So what does this then mean in terms of an dose exposure response context? So we put then these 2 things together. And what we see here in terms of LNG concentrations over time, simulating out for a normal weight subjects with a BMI of 25 or less, we see that the concentrations are well above the threshold concentrations in terms of troughs at steady state for Pearl indices of 2 in red, 3 in blue, and 5 here in orange. But if we then put then worst case scenarios on the table in terms of DDIs and then increased body mass indices, then we see that we actually getting into a concentration range where we're starting to flirt with the respective efficacy thresholds. All right. So again, we were fortunate when we wanted to then implement or make inferences of the oral absorption model towards like long-acting formulations, in this case implants. So we had access to data of implants over the course of almost 5 years. And so the way this data was generated is that implants were taken out of women over time, and the amount of levonorgestrel remaining in the implant was then basically measured. And we used that information on the kind of in vivo release, ex vivo measured in vivo release, and then use this then as the front end for the PBPK model framework that we developed and simulated out what we expect. And what we see here is that, and these are just like simulations overlaid with then actual trial observations, that we are, actually in fairly good shape of being able to predict what's happening for up to 60 months. Okay, so again, what we then can do is, of course, play what-if scenarios, and what you will see here is a couple of things. Number one is that the systemic exposure that you get from implants at the approved dose level is generally lower than what you would get after oral hormonal contraceptives. And so, of course, you say, okay, Stephan, this is great, but show me that it works. And so what we did here is that we overlaid, again, the model-based predictions with the clinical observations that we had from the literature. And I think we are in fairly good shape here. So what we also found was that when you looked at reported pregnancies, then you see that the incidence of pregnancies goes up over time. In other words, as the concentrations decrease. And I think this is quite nicely in line here with our predictions, as you then basically get closer to the efficacy thresholds. You, of course, can then also then simulate what you would expect in hypothetical scenarios. So, for example, what if we dosed rifampicin at 10 milligrams per kg QD for 4 months, so in according with the CDC guidance for latent tuberculosis. And you see, of course, that this would significantly decrease your concentrations and certainly put you like in the risk of unintended pregnancy, and you would probably need backup contraception in this particular case, since you cannot just like take the implant out. And it's also hypothetical scenarios like this. What if we increase the implant dose? That's probably more like of a theoretical concern, because it's probably much harder to just like put an extra implant in for a limited period of time. So we talked a little bit about exposure matching approaches. And so when we looked at where we are, is that we are now in the shape to basically make inferences about what's happening for levonorgestrel for different formulations, for different body compositions, and also interactions with inducers as well as inhibitors. But recognizing here that levonorgestrel has a relatively low fraction metabolized via 3A4, so what if we use the concept from pediatrics, in other words, exposure bracketing, and then looked at a second progestin. In this case, we picked trospirinone, which has a much higher fraction metabolized and is available as an oral formulation. So we basically, and then have a validation case. So for example, ENG in between. So essentially, we follow the same workflow for trospirinone and ethinyl estradiol. And we were again fortunate to work with colleagues from Bayer that provided us with access to individual patient trial data from 20-some different trials, and then overlaid the model-based predictions with the observations here, in this case, concentrations of trospirinone over time. And I think we can capture these data reasonably well. So we can, of course, then ask questions in terms of what happens for inhibitors as well as inducers. And again, when you look at the predicted versus observed ratio, I think we are in relatively good shape. So question then is, of course, are all CYP3A4 inducers created equally? And so in terms of PK, the answer is no. And so again, this is a surrogate of the fraction, or the result of a fraction metabolized. And what you see here is that trospirinone, given that it has a higher fraction metabolized, is impacted more because the AUC ratio is lower as compared to levonorgestrel. And when we compare these results to a prospective clinical trial that was conducted by Bayer, I think we are also quite nicely in range what we see for trospirinone. We are not quite there yet for LNG, but at least I think if you have like the twofold range, we are at least in range to be able to predict what's been observed in that dedicated clinical trial. So what always bothers me here is that we and I think I mentioned this during the symposium, is that we take like isolated pieces of evidence and then again call it a day. Drug-like interactions are no different. It's not a PK only question. And so we need to interpret like these findings in a PK/PD context. So far, I think we know what's happening in terms of PK. In terms of PK/PD, we need to integrate information. And so what we did is we integrated information across progestins for Pearl index using a concept that's not new, that has first been published by Black and Leaf in the 1980s using the so-called operational model of agonism. So where you use a similar concept for what you have in PBPK, so distinguishing between drug-specific and biological system-specific parameters. And so what allows us then to do is to integrate information for Pearl index. And again, you know, the challenge that you have that you're at the top of the exposure response profile with a secondary marker, so ovulation rate, where the dose range is much wider. And so what you then can do is that you can then start to come up with individual exposure response profile for Pearl index, for levonorgestrel and drospirenone, as well as ovulation rate. And so we then took this one step further and basically used the variance covariance matrix approach to simulate transducer ratio pairs, ovulation rate and Pearl index. And then this puts us then into position to actually have a link between Pearl index and ovulation rate. And then we can come up with simulated concentration response relationships for levonorgestrel here on the left, for both ovulation rate, shown here in blue, as well as the variance or the confidence interval, as well as Pearl index, and drospirenone on the right. And so what you see here is a couple of things. Number one, you know, the curves, you know, are not overlapping. You know, obviously there is, you know, a gap between ovulation rate and Pearl index, but you also see that the doses of levonorgestrel used are not necessarily completely at the top of the exposure response profile, but so you're, you know, starting to get into the sensitive range. And so if you then simulate out what happens in the presence of rifampicin or carbamazepine, then you see, you know, it's starting to become a bit more sensitive. In comparison, drospirenone is dosed much higher. So in other words, you're really at the top of the exposure response profile here. And so then I expect the impact of rifampicin and carbamazepine as strong CYP3A4 inducers to be less pronounced. Okay, so then of course we can translate this then into Pearl indices. So we are somewhere in a range of like 1.8 to 2.3 for levonorgestrel, and then around 0.3 in terms of Pearl indices for drospirenone. What we then also can, of course, do is then that we simulate out what happens in terms of DDI scenarios for healthy subjects as well as overweight subjects. So what we see here is in the absence of DDIs, the Pearl indices are actually the baseline for levonorgestrel is higher as compared to drospirenone, because again, it's not dosed at the levonorgestrel is not dosed at the top of the exposure response profile. However, if you then look at the impact of CYP3A4 inducers, that you see that, not surprisingly, of course, that the relative risk, you know, is higher for drospirenone in terms of a change from baseline, because you have a higher fraction metabolized as compared to levonorgestrel, and you can do this, of course, here for rifampicin as well. And so, so the relative risk in Pearl index for drospirenone is higher as compared to levonorgestrel. And to that extent, I also agree with the new FDA guidance here, where it says that, you know, fraction metabolized is important. Where I disagree here is where it says that we basically need to conduct efficacy trials using clinical endpoints, because I think we can, you know, simulate this out. And what we see here is that the absolute risk in terms of Pearl index is actually not significantly, maybe not lower, but at least not significantly different for drospirenone for levonorgestrel. In other words, that the difference in PK probably doesn't translate over to PD, which is of course important for a new drug development program, since you're basically required to look at DDIs with hormonal contraceptives, and you may be in a position to have to do a dedicated DDI trial. So what happens then if we join forces with real-world evidence? So the idea is really that we use a triangulation approach here. So where we basically strengthening causal inference by integrating different approaches. And so what we did again is looked at the number of unintended pregnancies in the presence of concomitant CYP3A4 inducers using antiepileptics as a case example. So levonorgestrel and trospirinone. And so we used, go back to your question, market scan data. So it's a private health insurance database. So the study population were female, obviously of childbearing age, no fertility or ovarian dysfunction, nor hirsutism. Obviously, you need to have like an indication or of epilepsy or a mood disorder. And with the exception of topiramate, no teratogenic use has been, or drugs with teratogenic use have been used here. And we need to have like more than 6 months of data. So the study cohorts, we looked at combined hormonal contraceptives for levonorgestrel and trospirinone together with antiepileptics. And so basically what you find is when you look at the rate ratios for the unadjusted data, then yes, if you compare levonorgestrel to trospirinone in the presence of ethinyl estradiol, there's a 70% increase. However, if you then adjust the data analysis for biases and then compare also, or also take the confidence intervals into consideration, you see that this confidence interval is overlapping 1. In other words, you don't have a statistically significant difference between levonorgestrel and trospirinone. Of course, you can then also formulate more questions and hypotheses in terms of what happens for other progestins and with various factors metabolized, different binding ratios, and then also compare notes in terms of unintended pregnancies. And what you see is that overall, I think we are fairly in the same range here. So to summarize, it is important, and I'm speaking primarily to the trainees here, that we are not having the mindset, okay, I'm the world's expert in PBPK modeling, so I'm only using PBPK to answer like every question under the sun. It is important to pick the right tool for the right question and recognizing here that different tools are being used. As far as I'm concerned, we are talking too much in terms of like my model, my paper, my grant, by whatever. It is not a modeling competition, it's a modeling continuum. So, and I think we really need to integrate like all the data that we have. And if you can solve your question that you have as an NCA, then, God bless. Okay, so to summarize, so what we found here is that following the oral administration, levonorgestrel plasma concentrations in terms of troughs at steady state are 410, 250, and about 140 to achieve brilliancies of 2, 3, and 5. If you want to compare these values to implants, or for example, also use them for the development of long-acting injectables, average values are probably more important. Body weight and CYP3A4 inducers are important for levonorgestrel because they decrease levonorgestrel exposure. We can predict for levonorgestrel at least what happens in terms of exposure for up to 5 years out. Not all progestins are impacted equally by CYP3A4 induction. We can, make then inferences about 3A4 induction effects using a bracketing approach, obviously taking then inhibition, body weight into consideration, and then translate also to implants. We can establish a link between ovulation rate and Pearl index. And so if you put this in a PK/PD index context, what we will see is that the relative impact of CYP3A4 induction is higher for trospirinone compared to levonorgestrel, but I would argue that the absolute impact is maybe not lower, but at least non-significantly different between the two. And overall, I think also our analysis results align nicely with real-world evidence. Now, obviously, I'm the cheerleader of a relatively large team of collaborators. So thank you to everybody who has supported this team, this project financially, intellectually, and emotionally in times. So thank you. I was very fortunate to work with a lot of great people throughout my career, and I'm hopeful that this will continue to be the case. I also learned, coming to Indianapolis, that you should be grateful for and need to work with what you have. Weather being one of them. So we actually started a new training program that's called the Florida Winter School, which is basically intended as a hands-on, on-site, one-week workshop for early stage professionals to learn more about PBPK modeling, what's going on behind the scenes, as well as QSP. We just had the first iteration in January this year. I think we had a great turnout, about 30 folks, 8 different countries, 4 different continents, and we are intending to move these efforts forward. And of course, if there's any interest or like more to learn more about it, be happy to share some additional information. With that, I'd like to thank you for your attention.
Questions? One question, please.
Thank you, Stephan, for the great presentation. And I have one question. In terms of the BMI, is for all the progestins, we have the same impact of DDI for all of them, or is
So in terms of PK, no.
Okay. Thank you.
Sorry. So yeah, again, thank you for the presentation. I wanted to, my question revolves around the induction of CYPs by rifampicin. So as far as I'm aware, that induction can take a couple of days via just the turnover rate of CYP3A. So I wanted to ask how the interaction might be different at the beginning of rifampicin therapy and after discontinuation for the same reason. CYPs might stick around for a week or two after discontinuation. So how might the interaction be managed differently clinically at those 2 time periods?
Yeah, no, you're completely correct. I mean, obviously, induction means that you need to make additional enzyme, additional protein, so which takes time, and so that it takes time, in both ways. And so, if there's a concern, then there's backup contraception is something that you should consider. Obviously, what I haven't talked about today yet, but you can use the opposite scenario as well in terms of CYP3A4 inhibition, and then see where you are in terms of like bleeding events, so to basically get like a better feeling in terms of forgiveness that may impact adherence of the medication.
All right. Well, before we close our morning session, I suspect some of you may be heading out for other things before our tutorial this afternoon. So thank you all for staying through. We look forward to our tutorial session this afternoon. And for those who may be taking off, we will see you hopefully next year. Thank you.